Hi everyone. Good afternoon, good evening, wherever you're based out. I'm Santosh. I have my friend Tiago. We both are here to speak about AKS networking best practices. How do you optimize it and more into cool stuff? I'll leave
Yeah.
Tiago to introduce himself.
Hey, hello everyone. Thanks for having me. Kia ora. Okay, let's start.
Well, good. Before we get the floor set up, just want to make sure what is the challenges we have on how do we optimize by the best practices solutions which we're going to talk today. Just want to speak about the performances issues like scalability, performance. Like if you have a AKS workload or application workload, you want to make sure it's scalable with the networking. You don't want to run out of IP shortage or something kind of scenario where you want to meet them. Then you just think back, okay, I should have planned that earlier before I step into a solution. So that's the thing, like IP planning, making sure it's secured with the networking stuff. Security is always a core part of any applications and observability and performance. So that's a kind of a things today. And we'll move on to the next slide with agenda. Today's agenda is to speak about the networking model in AKS. What are the different options, which is the best to use, which is getting kind of redundant and legacy out, and more about in the securing your AKS workload with the networking as an option, observability and traffic management with ingress and egress, so that just gives you the best practices to use across both for the inbound traffic as well as the outbound traffic. And lastly, we'll summarize with the key takeaways. Yep.
Cool.
The next
Thank you.
slide. Good.
Yeah, before we can start picking on any network model, we really need to think about the IP planning, right? If um, if you are already familiar with network, you know that's IP is not a endless resource, and your VNet CDR must be large enough to accommodate all the node subnet, the pod subnets, the services, and everything without overlapping. Otherwise, you will need to overlay your network, and that can create some overhead in performance. So it's really important to spend a few minutes to really plan how you will have your network for your VNet, your node, your pod, and then once you have all these really planning, you can select what model of network you can have. So when you are ready, you can take off. I send back to you, Santosh.
Well, good. This slide speaks about the AKS basic architecture. Just want to give you an understanding of how the AKS has been as a managed Kubernetes version within Azure. Like, as someone knows on the Kubernetes basics, the control plane is managed by Azure. You no need to worry about anything like API server, control manager, schedule. Everything is managed by Azure with Freecast. And the rest of thing is just need to manage your nodes and pods, which is customer owned. That just belongs to the customer responsibility, and the control plane is taken out into the Azure. So this is just to give you an understanding about how does it AKS works in the networking stuff. Next, go to the next slide, which brings up the networking models. As Thiago has pointed out, we just want to make sure the first step is to plan the number of workloads and the workloads coming into the AKS and want to make sure what is your usage and application going to scalability. The next step is on networking model because Azure provides a couple of models in the networking model. The one thing is first thing is called as Azure CNI, the flat model, the standard version, which been in the long time here, which provides in the pods and nodes IP address directly from the AKS VNet. The pods can be accessed directly from the outside of the cluster, and pod to pod communication goes from the same IP address range within the VNet. And this requires a larger CDR to be planned and making sure you have the scalability capacity to when the workloads getting expanded and horizontally and vertically. In the CNI flat model, we have two options. One is Azure CNI pod subnet, the Azure CNI node subnet. The pod subnet, what happens is it assigns an IP addresses to the pods from the separate subnet within the VNet. Even though it's within the VNet, it's from a different subnet. It's a distinct from the AKS workloads are hosted on the node side. This is the most recommended if you want to use a flat model. You don't want to have some kind of NAT and overlay networking, then this is the best to go with this. But again, of caution, you need a larger CDR for this. The second option within this is Azure CNI node subnet, which is kind of a legacy, which is not the best practice and recommended way to go forward. what happens in that method is it assigns IP address to the pods from the same subnet of the AKS cluster. So the pods and the nodes get the same IP address range within one single subnet within the VNet. Actually, the legacy flat network model generally recommend to go only if you have this for kind of a testing. You want to just quickly spin up and just use it for a POC and testing model. Then this is the best to go with a node subnet. But I would recommend, and me and Nitya will both recommend to go for CNI pod subnet. Want to keep consistent across your workload model so that you can just elaborate the same scenarios in all the dev, prod, non-prod production, whatever it is. The next slides provides the Azure CNI flat and standard in high level and what it is. It just gets a direct access to the VNet. The pods are within the VNet, the pod's IP address and the node's IP address coming from the same VNet. Caution here is requires a larger IP address range. Make sure IP planning is part of your initial start before we get into the CNI flat model. The next option is CNI overlay model. What is it different from the CNA flat model is the pod IP address will have an overlay IP address. What does it mean is overlay is it gets an IP address from a different VNet, not within the VNet of AKS cluster. If you look at the diagram here, you see the first one VNet is which network which is managed on AKS cluster, and there is another VNet which has been used to host your pods in a different VNet. This is a recommended method and mostly usable across widely in Azure. And this provides you the highly scalable networking. And what happens here is the IP address of the CIDR in the AKS VNet and the CNI overlay VNet will be different. So you no need to worry about your scalability of the IP address. It just goes over there. And you just need to have a NAT, which is managed NAT. Actually, you don't need to worry about anything. It just gets the traffic from the pod to the node via the managed NAT. And pod cannot be accessed outside of the cluster. And that helps you to keep your most secure way. So the reuse of pod overlay space across the cluster without a conflict. The pod traffic leaving to the nodes are netted to the node traffic. And it supports both IPv4 and IPv6 actually. The next slide will give you and what we discussed earlier, like it's a difference on the CNI flat model to CNI overlay is like the decoupled pod IP address. The pod IP address is different and the node's IP address is different. On the overlay network, pod receive an IP address from an overlay network, which has been like VXLAN, the networking encapsulation methodology, and it decouples the IP address assignment from the VNet's IP address. The performance wise, it's the slight overhead, but this is one of the best scalability option within the two models actually. The next slide will give you the Azure AKNS networking models comparison. Just it has two model, CNI overlay, CNI flat. Overlay will have a decoupled IP address. The flat model will have the IP address on the same VNet. So it is just giving you an option to compare it and best to choose it. And most recommended network plugin choices in the next slide will be speak about Azure CNI, overlay model. The CubeNet we didn't discuss because it's a legacy. That's one of the first networking model introduced in the AKS when it was first introduced in Azure. So it is not to be used at all. I would say recommended not to, and it is getting retired sooner in 2028, if I'm not wrong. And the CNI pod subnet is probably the second option to be used out of this. I'll leave it to Thiago for the next session, next sections.
Yeah, thank you. So once you decide, you can decide both on overlay or the flat one. And recently, Azure has adopted the Cilium powered CNI. And that Cilium, if you're not familiar with this technology, they use eBPF, and that give you a better performance on the workloads and on the data plane, since it can bypass some steps in the kernel. And that is an option that you can use in both models. So just a little quick introduction on how the Cilium works. In the classic or the classical CNI, you have the same layer for the data plane passing from your pre-routing, the forward, and the post-routing, and this can cause it is a overhead. And Cilium bypass this by using eBPF, is a sandbox program in the kernel space that do this path for the data layer, and make it performance and also have less CPU overhead. A little comparison and a benchmark. If you have this, this graphic is 50K requests per second, up to 5,000 pods. Both Celia and the Kube proxies are quite similar, but when you pass this threshold, you can see that the latency it's better performance by Cilian than the Kube proxy. One thing that it's important to note is that Cilium can only be used by uh, Linux nodes, not on Windows yet, but the eBPF on Windows are coming soon. I hope we will get GA for that still, but not on that. Okay, so once we have all this defined, the model, we can go and talk about the network policies, right? So it's essential to plan how you're gonna do the this part from day zero. So just a few fundamentals. You can start by applying default deny. So you close all the ingress and egress paths. And then from there, you can start with the minimal rules, create some control for ingress, and then you start your rollout for applying policy in previous environments. Then you can test that before going to production. And then you can you can continue monitoring. This is the basic idea on how you can start in your network policies. But how you can, so, oops. Oh, I jumped one slide. Oh, I don't have that. Sorry, I may have just, okay, no worries. I had the one slide for, let me see if I can bring it here. Sorry for that. But
All
it
good,
is
mate.
just, anyway, without the slides. The idea is that we have some engines for applying and enforce these policies, right? So the three main engines that we can use in AKS is the on Azure Network Policy Management. That is really quick to use because just one button click or just one command on the CLI that you can enforce that, and it is easy to apply. But it is only for L3 and L4 rules, and other than that, it can only be used in Windows nodes. But it gives you the Prometheus metrics, and also in the same time, it can become a bottleneck if you have a really large cluster. Another engine that you have is the Calico. Probably have heard about it. It's a well-mature network interface for applying policies, and it can work really well on Linux clusters, but in the Windows workloads are not covered. So it's still using IP tables. And as again, I told you before about Cilium. Cilium come with out of the box. They can enforce the policy networks, and they enforce the policy networks directly into the in the kernel space, so that also get a really ultra low latency. And with that, you can enforce these policies. Then I can jump. Yep,
Yep, all good.
it's correct. Yeah.
The next section is about Ingress best practices. As part of AKS, the application load balance and traffic management plays a key role where it comes up to the layer 7 solution. What are the Ingress solution has been available? You have to make sure the security has been taken care of at layer 7 level, like enabling PAF and making sure the end-to-end TLS encryption has been enabled from the client to the server end. And we have a couple of options here to look around. Let's go through the next slide and see what are the options available for us. The first option is application gateway for containers. This is one of the latest services been added as part of the application gateway family. This provides a dynamic traffic management for the workloads running in the Kubernetes cluster, and it extends the Azure application load balancing portfolio as well. The Azure application gateway is a Azure Application Gateway for Container is an evaluation from another product within Azure is something called Application Gateway Ingress Controller or AGIC, which is being used for on the layer 7 load balancing. What is the changes from AGIC and AGC is like AGIC has a little bit of time required to have the resource management. Say, for example, if you create or upscale the application as part of your Kubernetes pod, there is a subset of time required to making sure the resources getting changed is updated back into the application load by N7. With this current modern technology, right, that even the subset of microseconds will have a delay in the application. So that's when Azure has brought up something like application gateway for containers, which will be a real-time update to that actually. In addition to that, application gateway for containers can support the gateway as well as the ingress, the both options in the Kubernetes actually, where AGIC can only support the ingress but not the gateway. Let's get into deep diver in this. How does application gateway container works actually? No, Diego, just go back to the same slide.
Sorry, sorry.
Yeah, that's okay. All good. How does it works? Application gateways container is made up of three components as listed in this diagram, like application gateway for container resource, the front end, and the association. What this association belongs is it's just making sure the AKS node or the application where it hosted have a direct relationship between the AGC to the virtual network. The front end is where it just plays from application gateway, it just provides you a FQ2N, which is being used for accessing the application. And the container resolution has to be enabled to the application gateway. An application gateway of containers resource is a parent resource that deploys the control plane. That's where the control plane is responsible for orchestrating the proxy configuration based on the customer on the back end of the application. Like if you scale up, scale down, everything is managed on this control plane. Next is like the container front end. The container front end resource is a child resource within application gateway containers for the parent resource. An application gateway for containers association is nothing but it's a child resource within AGC where it has one-to-one mapping for the virtual network. So in addition to that, the containers AGC has a small two subset of running pod will be allocated, which will monitor the changes within the Kubernetes workload and just points back to the application gateway saying that, okay, the application is scaled from the pod number 4, they've been scaled for pod number 8. There are 8 pods. We have to add the 4 pod back into the backend into the AGC. So making sure if anything changes, it can do a dynamic traffic back to the application. That's AGC. Let's go back to the next slide and go and speak about AGIC. Application ingress controller, application gateway ingress controller. It's similar to the AGC, but I said it doesn't support the gateway resources from the Kubernetes. And it has a slightly a lag in the timing where it just exposes the services back into the pod will have a little delay. And the container networking AGC can support all the networking models, which I specifically called out like kubenet, CNI, CNA overlay, and Azure CNI. In AGC as well, it doesn't support kubenet, but it supports CNI overlay and Azure CNI. So it is best to use AGC, sorry. It's not AGIC, it's best to go with AGC. And there is a migration path as well. If someone is currently using AGIC, the ingress controller, if they want to uplift their workloads from AGIC to AGC, there is a migration path for you to consider to make sure your application is been getting transferred into the latest version. I'll pass it back to Thiago for the next slides.
So once we have defined our ingress, we can go to the egress. And by default, the AKS pods, they have a simple hop that passes to the SNet, the pool. And that can be really a bottleneck because you will run out of IPs and ports and you don't know exactly where it's coming back from. So the best way is to simply avoid that and don't use the default ingress. So you need to build your own how to say your own tool of inspection to see where your traffic is going to. So this can allow you to select if your traffic should not go out. And there is two main ways to do that. You can use either the Azure Net Gateway. This is really good. That can scale really well with your cluster. but you will not be able to see the full qualified domain name and no threat intel filtering as well. But at the same time, is really low cost. Or you can use the Azure Firewall. If you need for more deeper inspection, Azure Firewall can make you understand from layer 3 to layer 7, so up to the application, and it can control where the roads are defined, all passing this from this toll station. So when you apply this egress, making this really secure, you can thinking more on the how you can make your cluster really private. So yeah, I missed my slide. My slide of policy was here, but let's continue. On the AKS private cluster, some organizations they really needed to have a more secure environment, and the workload data cannot go out for the public internet. And this is how you can make it AKS private cluster all inside your own VNet. And this will create a private network just allowed by your internal VNet after your firewalls. And then you can create your private FQNDN that will be a private load balance. And then you can select, you can, what's the word? You can resolve that to your
Yeah.
private IP. And then this will create the communication between your nodes and pods, but only inside your private internet, private network. But then it don't have access to public ingress, but the nodes still can work. And how we can make this integrate with IP, the API server? There is this API server VNet integration, and this feature give you access to the control plane endpoint as an internal load balance, and this delegate the subnet to the VNet. So when the node in your class asks to work, it simply hits this private FKND. So, and then it will go directly to your network. So no matter if you are running in a public or private cluster, you still can use the IP API server VNet integration. So this is how you can really build a really lockdown cluster. So it will operate with any no public facing uh, problem. So this is a really big problem for API, right? On the Kubernetes, almost everyone runs in the same endpoint and the port. If you know the IP for our API server, it's a bigger problem. So once you have the cluster up and secure, our next mission is the visibility and how to control everything. And on that, we have the advanced container network services that give you the observability from both Cilium or no Cilium based network. And this gives you metrics on your, how to say, giving metrics through the Prometheus to to Grafana, and you can see that in the UI. And it you can see where is the spots dropping of packets, the TPC resets or surge of traffic volumes. And using the Hubble, you can see the topography of the network as well. And this gives you a really nice
Just a heads
graph
up, like
trace.
we're just reaching the
Good.
time.
Yeah, we
Oh
are
yeah,
on
yeah.
time. We will
This
Reaching the
is
time. So
just one
we
more
are on
slide.
time. No worries. Yeah.
We are on
Just one
time.
more slide. This is just yeah. Thank you for that. So and then this is another thing you need to after you have all your cluster really well, you need to observability is really important to know and control the operations of your AKS. On the operations side, as Santosh has mentioned, the Kubernetes is retiring on 31 of March on 28. So please go to this link here and update if you still use the Kubernetes. And that's it. Thank you so much. We are on time.
We
You're
are on time.
Yeah, any
Thanks.
questions or
Thanks,
yeah,
we
Balkan.
don't have time for questions?
Any questions?
I,
Yeah. Any
I have a
questions?
Yep.
question in a scenario. So let's say like, well, clusters that have been provisioned in the past and they not necessarily follow the best practices. I've heard about cases where like there's this IP exhaustion, right? Probably like people using the Azure CNI flat model.
Yeah.
Is there like a easy transition to the what's called the overlay model?
Not a direct transition you have to do it. Probably it's not available at the moment. There is no migration from this way to this way. You have to slowly migrate the application back into the new. It's kind of a brownfield setup, like setup. You have to have something present, then you just migrate slowly and back into that way. Yeah, that's a great question.
Yeah.
Oh, all good. Yeah. Let's see like if we have like any more questions. I think that's us. And well, thanks again, Thiago and Santosh.
No worries,
Nice
man.
meeting you virtually, Santosh.
Yes,
Hope
Marcel.
like one day we
Thank
can
you.
have a catch up. Yeah,
Yeah,
and thank you. Thank you for joining. And we're having the next
thanks,
session
guys.
come next.
Thank
Yep.
you.